And so I've done this experiment with students actually 3 times now. So I've got a little bit to say about how it's worked, and it's a really cool, really engaging activity. So I'm really excited to be part of this. So thanks, Heather, for the opportunity.
Amazing. Just so everyone knows, we are going to record this presentation so others can access it. So I just started that right now. My name is Heather Delagran, and I've been an education producer for Ocean School since 2017. I am a sorry, my 3-year-old's calling me. I am a former teacher. I used to teach geography and social sciences, but have transitioned from several years now to production. So I'm an education producer now. Without further ado, we're going to chat today about plastic. So before we begin, a little land acknowledgement. We'd like to respectfully acknowledge the traditional guardians of the lands of where Ocean School is produced. Our team lives and works in the ancestral and original homelands of many nations. However, the National Film Board of Canada's headquarters is located in the homelands of the Haudenosaunee and Kanehake peoples, and it's also where my home is. Kim, would you like to add as well?
Yeah, and I'm coming to you from the traditional and unceded territory of the Liquitao people, the Waiwike, Waiwikam, Comox, and Klahoose First Nations, also home to the Hamalko and associated nations from around Vancouver Island. And so grateful for the time I get to spend on this territory, because it's very beautiful, as we're also fortunate to be in our respective places. Back to you, Heather.
So, we just want to acknowledge that water is a resource that all life needs, and it's important that we can both care for the water and the land. I don't know where all of you are coming from today, but in Montreal, spring always reveals our toxic courtship with plastic. All waste goes somewhere. It doesn't magically evaporate like the snow when garbage trucks swing down the street. And so when the snow melts away, we can find plastic just about everywhere in Montreal. And the accumulation of plastic waste in our landfills, our backyards, our waterways, and ocean has resulted in ecological damage. But Ocean School's here. We're here and we're committed, like I guess all of you are today, to working towards a more sustainable and equitable future where we can reduce our dependence on plastic and take responsibility for the impact of our actions on the land and water. And we really recognize the importance of building meaningful relationships with Indigenous communities and strive to collaborate with them in ways that promote respect and understanding. So that's where we're going today. We're going to do a really quick tour of Ocean School and the plastic collection that we've just launched. Afterwards, we'll take a look, we'll watch the video Micro Mystery, and then afterwards, Kim is going to take us through the activity in a lot of detail. So I'm going to share my screen and take you guys over to Ocean School. Everyone see everything? See my screen? We're good?
Yep, I can see it, Heather.
Okay, great. Okay, so here we are. This is our resource library. You can find it at oceanschool.nfb.ca/resources. And you can use this resource library. It's got 147 different kinds of media in it. Ocean School produces videos, 360 videos, augmented reality, assessments, interactive experiences, virtual reality, all kinds of stuff. And every single piece of media comes with an activity. You can filter in this library by collection, by individual resource, by grade, by time, by subject. So you can put pretty much whatever you're looking for. Let's say you're looking for sustainability, something about sustainability. And you're going to get up a whole host of resources. Today, we're going to look at the problem with plastic. So this is one of our 3 plastic collections. There's 2 smaller collections. We have Plastic in My Habitat and Plastic Then and Now, which are smaller versions of this collection. This collection kind of has everything in it. All of our collections come with an overarching inquiry question. So in this case, it's how can I be part of the plastic solution? You'll always find a description of the collection here, as well as information about what grades it's suitable for and the subjects and key concepts. So this collection, you will find content about Canadian scientists. So we've got scientists like Chelsea Rockman, who's kind of like the rock star of the plastic research world. We have Max LeBryan, who is researching the impact of plastic on our ecosystems. We visit Oceanwise, the high-tech plastic lab in Vancouver. And we also go out searching for ghost gear with Coastal Action. So lots of different kinds of content here. If you scroll down a little bit, you'll see all the different pieces of media. So you'll see videos, there's some interactives with virtual reality. You don't have to have the goggles. All of our stuff scales down nicely. So if you don't have the goggles, you can still use the virtual reality experience just on in your browser. So just a little bit different. So you can see all the different kinds of content, lots of different neat little interactives. And if you click on any of these, you'll get a little bit more information about it. And you can preview the video right away. All of our content does have accessibility features like describe video and closed captioning. Unfortunately, for these videos at this very moment, it's not quite ready yet, but those features will be ready very soon. There's always a transcript available as well, right here. And then you get the activity that comes with the piece of media. Again, you get some information about that activity. In this case, it's a scavenger hunt. So you're looking for different types of plastic around you. And there's some critical thinking reflections that go with that. And to preview it, you just click preview, and then you can just scroll through the slides and see if it's something that you want to do. And if you keep going, you can open it in a PowerPoint, open it in Google Slides, and there's the other support resources here. Just going to show you a couple more features, and then we'll dive into some content. You can assign this collection to your class, and you can turn on and off any piece of media you don't want to appear in the collection, so you can customize it. And the same thing for the activity. If you don't want the activity to appear, but you want them to watch the video or do the interactive, you can just turn off the activity. When you're done, you can generate a student link, and then you can share directly to Google Classroom, to Teams, or you can cut and paste the link and deliver it however you want. You can also view the collection as a student. So the student experience is a little bit more streamlined. So that link that you share would send them here. They get the title, the overarching question, and then they would get the media presented to them. And whenever they click on a piece of media, like the plastic cycle, again, they get a little tiny intro, and then they would dive into the media. So this is actually, I'll show you this since we're here. This is a little interactive experience. It's super simple. It's really showing you how plastic moves through our world, just like carbon and water moves through our world. So you learn a little bit about the system, and then you can click on the different things and learn how plastic's moving through the lake surface and the water column, how air and clouds transport microplastics, how rain and snow carry them. And you can also go underwater and see how plastic is moving in ecosystems. When you're done, you just click, I am done. And then for a student, they can click go to activity. It offers the two different formats for them. And then the activity automatically opens and they can add it to their drive if they've chosen Google Slides. So we're going to go back. I'll just show you maybe a couple other of the interactive experiences. This one's called Plastic in My Watershed. We're going to be showing it in a webinar next week, or go into detail about the activity in French though. And so this one is really cute. We made it in collaboration with the trash team out at the University of Toronto. So there's this little raccoon that guides you through, and you're learning about different sources of plastic pollution in a watershed. So you learn what a watershed is, and then you learn about all these different sources of plastic pollution. And once you're done learning about the sources, then you're challenged to match different pieces of plastic pollution to their source. And if you get it wrong, it just flies back. So you're just matching the different pieces of plastic that you're presented with. I think I've become an expert at this. Well, one more. Finally, the last step, after you get your little correct, the last step is a little flip card game to help you learn what microplastics look like for each of these things. So you can click on the plastic bag and you can see what the microplastic would look like for any of these, which I find really helpful. Fibers, those are something we'll talk about today. I think, what time is we at? I'm going to stop there because I want time to go through the activity. So we're going to show the video and then we'll talk about the activity. Before I move on, is there any questions about what I've shown you? Sajid, I can't see the chat, by the way. Oh. If you think of any questions as the video is playing, throw them in the chat and we'll address them after the video is done.
Just to let you know, the chat is disabled.
Oh, okay. I will work on fixing that.
It's estimated that 8 million tons of plastic end up in our ocean every year. That's like one garbage truck emptying into the ocean every minute. But of that 8 million tons, much of it is hard to see.
So microplastics are plastics that are smaller than 5 millimeters, about the size of a grain of rice. Some plastics are born that small, right? Exfoliants in hand, sanitizers, that sort of stuff. Those start as microplastics. But most large plastics, once they're in the ocean, which is the strongest thing in the world, they get ground up into smaller and smaller plastics, all the way down to the nanoscale.
Researchers at the University of Toronto use sievins to trap and track trash along the local waterfront.
Here is a piece of microplastic. So you can see all the kind of the little stuff is starting to float up. Here I see a bit of a white pellet, another white pellet. So this is a larger fragment. Eventually it'll break down smaller and smaller. When I first went out into the middle of the ocean and I saw how much plastic was floating around out there, most of it was microplastic. It looked like a soup of confetti floating around on the surface of the water with maybe a buoy and a fishing net and a bottle here and there.
People were thinking, oh, ocean plastics are like plastics on land, but in the ocean. Not true. When they get to the ocean, they are tiny, 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 and they act differently when they are tiny, tiny.
The reality is it's breaking down into these smaller and smaller pieces, which then are available to more and more wildlife because they can literally fit it in their mouth.
A fish eats plastic, and another animal eats that fish. Soon, we have plastic moving through the food chain. So a tiny piece of plastic can become a big problem. So if we're going to stop it, we need to know where that plastic came from in the first place.
If I know where it's coming from, I can think about ways to reduce the input of plastic upstream so it doesn't end up in the ocean.
It's a micro mystery, and solving it starts with a search for evidence.
Microplastics are found everywhere throughout the world's oceans. We detect them in sediments, in surface ocean near our coasts, also in remote oceanic regions such as Southern Ocean near Antarctica or Arctic Ocean. We also find them in sea ice.
You would think that finding something smaller than a grain of rice and something as large as the ocean would be near impossible. But unfortunately, there's so much of it, all we need are the right tools. What are we doing here?
We're going to use this system to collect seawaters for microplastic studies.
We start by pumping water through a filter that catches anything solid.
So when the waters come through, the solids will retain outside the surface of the filter.
The next step is to remove anything that's organic, like seaweed and sand. Then we move in for a closer look and pick out anything we suspect might be plastic.
We then take that particle to the instrument called the FTIR. It's a forensics tool that allows us to identify what material these plastics are made out of.
You heard that right. The FTIR machine is a forensics tool, the kind used in criminal investigations. Our ocean detectives can use it to follow the trail of evidence to its source.
So the technique involves shooting a beam of infrared light onto a particle. That particle then emits an infrared light spectrum, which is unique to each an individual polymer type. It creates a unique set of sort of wiggles and lines, and different polymers will have different peaks in different positions. And then we're looking for a match between the spectra in the sample and those that we have in the library.
Okay, so you've done scans in the past, and you can compare it to a huge library of It's like getting the plastic's fingerprints or DNA, and then searching for a match. With this technology, we can find out a lot about a little piece of ocean plastic.
So you can see it's really hard to tell what the starting material was unless it has a really distinct shape, for example, like a pre-production pellet. Some are pretty easy to think about the source, and some are really difficult.
The more we investigate microplastics, the better we can be at reducing pollution in the future.
When I find a microfiber, a tiny little thread in my sample, I know that comes from a textile, either from clothing, from a towel, from furniture. Then I can think about solutions, for example, a filter on my washing machine to stop those fibers from going in the environment.
Using high-tech crime-fighting tools like the FTIR helps us get to the source of the problem. But other parts of this microplastics mystery are still unsolved.
We know that we're putting a lot of plastic into the ocean, and we know that plastic is going to last for a really long time. And so what is the presence of these plastics over hundreds of years going to do to our oceans? And we don't know that yet.
Big plastics do things like entangle whales, and nano and microplastics get up to very different things. And it looks more like participating in ecosystems in unpredictable and unknown ways. That's why microplastics matter, because we do not know what they get up to.
All right, I'm gonna stop sharing my screen. I think because I think the way the webinar was set up, we aren't able to turn on the chat. So if you have questions, just raise your hand, and we'll give you a chance to ask. But Kim, over to you. Let's talk about micro mystery.
Yeah, so the micro mystery microplastics inquiry lab is where students get a chance to see if there is any plastic or microplastics in their salt. And so when I've done this with students, we brainstorm like, what is salt and where does it come from? Oh, something was posted in the,
It was
okay,
me.
that was you. Okay, sorry. I was like, oh, the chat's working. So we talk about like where salt comes from, and you know, I ask the kids if they know if they have sea salt at home or if they're using like an iodized mined salt or Himalayan pink salt. We kind of brainstorm salts first. And then we get into, I've done this a couple of times now, and I've done it slightly different each time. The first time I didn't know what we were going to find, so I just let the kids go at the experiment. And so I don't know, Heather, if you can show a picture of the setup that I use, and then I can kind of speak to that.
Yeah.
And there's lots of adaptations. I know, Pam, you were saying before we started that you can, or that you might not be in a classroom situation. So there's lots of ways you can do this with materials that you have at home.
Okay.
If you don't have beakers, like mason jars would work fine, or even clear glasses. You know, like coffee filters, you can get them at the dollar store,
Sure.
and you don't need a funnel, like that sort of thing.
Mhm.
So yeah, if you can see my setup there, basically the procedure's super straightforward. You just dissolve like a teaspoon of salt. All of the, sorry to interrupt myself here, but there is a handout that you can download from the Ocean School page, the lab report, and it gives you like the step-by-step instructions as well. So I think the handout is actually relatively new, but it's awesome. And so, yeah.
It is here somewhere. It's like oh, here it is, the letter sized version. So we have a lab sheet that you can print.
You can print that. And so students, the ones that I teach in grade 8, they can follow this and set it up themselves. The first time I did it, I had it all set up at the front. And then students just came up and collected the materials. I used all the different types of sea salt that I could get my hands on, and had students choose 3 different types. So we got a really wide spectrum of the different salts. But basically you just dissolve a teaspoon of water or salt into some warm water, wait till it dissolves, and then you're pouring it through filter paper. And I've got it set up with a filter in a funnel on a ring stand clamp in my, because I've got science lab materials, but you could easily do it through a handheld funnel, have one kid hold the funnel with the filter paper in it, and then just pour the solution through. It's interesting because even the microscopes that I use to look at the filter paper, so once the solution's poured through, you let the filter paper dry out a little bit. It doesn't have to be totally dry. Then I use dissecting scopes like you can see in that lower left hand picture there, but you could use just a hand lens and you would probably be able to see some of those bigger fibers. I don't want to like give anything away, but it's totally shocking to see that there are for sure fibers in every sample of sea salt that I've tested in 3 different classes of students doing this lab. And there's no fibers in the Himalayan pink salt that I've found so far, or in the mined salt from underground. So it's pretty surprising, super easy procedure, really revealing for students. Students get quite surprised, and it leads to great conversations to follow up on that video. They've now seen it for themselves. It's in salt. They are quite amazed. I had one student who like got right on his phone and like, because on this one salt that we used, it was like guaranteed plastic free or something it said on the packaging. And he like got right on his phone and he emailed the company, like, this is what I just found in my science lab. So you could go off in all sorts of directions with students with that, like the interdisciplinary curricular connections, like letter writing, all sorts of things could be really cool. Yeah, there's all these extensions like right there in the activity that lead to really great discussions. I think, you know, from a science teacher's perspective, like it's all here as far as those curricular competencies that in BC anyways are kind of the backbone to our science curriculum. And this could be run, I would say, anywhere from like grade 3, 4, even all the way up to grade 12, and you would just adapt it and dive deeper as you know, like according to your group. But I think the procedure is simple enough. Like the water doesn't have to be like boiling hot. So as far as the hotter the water is, the quicker things are going to dissolve, but you can dissolve it in just sort of warm temperature water. So it doesn't have a safety element to it. The disposal is really easily, once the filter paper is dried, you just put everything either down the sink or in the garbage, especially since you've now filtered the paper out. So you're not putting the microplastics back down the drain. I had that conversation with students when I did this a few weeks ago. We're like, yeah, what if you just pour your salt water down the drain? And then those microfibers are still going back right into the system. What else can I say about it? We talked a lot in my class afterwards because what we found was fibers. And so where do those fibers come from? And I had all the kids look at their clothing labels. And we brainstormed on the board everything that their clothing said. So, you know, everything from cotton to nylon to polyester. And then we started, you know, I had them grab their phones or devices and I was like, okay, so polyester, what is that? And so lots of them didn't know that that's a plastic product. And so it was a really good conversation starter around like, what can we do with our laundry? We looked up guppy bags, which are one of those filters that you can install in the back of your washing machine to hopefully collect some of those microplastics. The connections and what you can do with it are really far reaching. And so for a really straightforward experiment, I feel like it's really mind-blowing for kids because it's super hands-on. They see it for their own eyes. Yeah, it's pretty interesting. I don't know, Heather, if that's like enough or if there's clarification. I kind of jumped all around there.
I think that's great. Does anyone, like, feel free to raise your hand. We're a small group, so feel free to raise your hand if you'd like to ask a question or have any comments. Pam?
So I guess what's surprising to me is that you don't really need special equipment to see the microplastics emerge from the salt. That was my concern in terms of doing the experiment, like that you would need special equipment.
We wondered that too when we first started investigating to see if this activity was possible. We actually sent one of our science producers into a lab to try different equipment. Océan?
I was just wondering if we could do this activity in a lake, like to find microplastic. Would it work?
Do you know what I would think? Like, because you wouldn't have that dissolving element, but you could still run water through filter paper and see what you could find. I think with just straight up water, you might end up with a lot more organics, like a lot more like little bits of algae and those sorts of things. So you would have to just look for things that look like those little microplastic fragments in the slides that Heather showed just a minute ago. But I would try it.
And we do have two other activities. So there's one called plastic. Oh, do you guys see my screen again?
Yeah.
Okay. There's one called Plastic on Trial Baby Legs, and there's one called Ice Cream Scoop. And these are really cool activities where you build your own data collection device. Baby Legs is a little bit more complex, and we'll find smaller bits of plastic because you're using nylon hose that you're pulling through the water. And Ice Cream Scoop is for younger kids, and you're looking at finding bigger pieces of plastic in the water. And these would be totally appropriate for rivers and lakes. A little bit different. You're not going to find like really small fibers and these these two data collection devices, but the activity takes you step by step through building your own device, collecting the data, and then analyzing that data. So those are really cool activities as well. And then I'll just point out, since I'm sharing my screen again, we do have a take action at the end of every collection. And this one offers 4 different actions. So there's 4 different little videos, one about a shoreline cleanup, one about searching for ghost gear, one from an artivist, Benjamin Bong Wong, who creates, he recycles thousands of pop bottles to create these viral images on the internet to raise awareness about plastic pollution. And then there's one about a zero waste store. And then we have a toolkit. And in this toolkit, it's a step-by-step guide to taking action for the ocean. So identifying the problem, planning it all out. And at the end, there's a whole suite of supporting activities. So everything from writing a letter to your MP to creating an infographic, organizing a shoreline cleanup, lots and lots of different tools to support taking action.
And this is super kid friendly. Like I have used this now with my students at the end for their projects, just as a big all-encompassing thing for their beach life projects. And it's super awesome as a resource. So you can be like, okay, what do you need to do? Well, why don't you take a look here and see what speaks to you. So yeah, it's great.
Any other questions? Thoughts, comments? We're at 7:03. We promised a 30-minute webinar.
Or 4:03 Pacific.
Yeah, or 4:03 Pacific. Anybody else? Any thoughts? Océan, your hands up, back up. Did you have another question?
Yeah, actually, this is Antoine, his father.
Oh.
We're the ones going on the sailing trip, and I was wondering, Is there, when we have those findings, when we find plastic and when the classes find plastic, is there any research that you're connected with that we can share the results or share the findings? I think it would be amazing if we can also bring the children to realize that they're making a difference and they're participating in some kind of international research or even a local one. Or have you thought about this?
Absolutely. We don't collect the data, but our partners at Oceanwise, for example, and specifically for shoreline cleanups, they do collect data. And so you can register your shoreline cleanup with them, and they have a whole data collection database for that. So they would be partners that we work with. We do have other for things like a BioBlitz, there are other resources out there as well and databases that you can use, but Ocean School specifically hasn't developed one. But great question.
Yeah, thank you.
I do think that data is power, and when you are engaged, doing more civic engagement, being able to say, hey, these are my findings that I found in our community. I think that also brings power to students to say, this is not just happening out there, it's happening here. Any other questions? Well, guys, thank you so much for coming. Next week, we have 2 other webinars. One will be in French, really focusing in on plastic in my watershed, and one in English on our, it's actually an interactive I didn't show today called Plastic Through Time, which is a time machine that takes you through the invention of plastic all the way to the end. And the activity after that is all about upcycling. And we have another teacher guest coming to talk about that. So if you're interested, we'd love to have you again. But otherwise, thank you guys so much for joining us. And Sajid, did you want to say anything else, or?
No, that's good, Heather.
Okay, great. So thank you guys once more. Thank you, Kim, for sharing your experiences with us. And we wish you all a great night.